Okay, this hour we'll talk about M02, which is the execution environment. And in this class, we encourage you to use Google Colab to write your program. And we also use Google Colab to demonstrate our algorithm and homeworks, everything else. Okay, we use Colab. The reason why we use Google Colab is it allows you to execute Python in your browser so that you don't have to have a very powerful PC um, or need any GPU card to analyze very complex data. So I'd like to show you some uh, picture about how Colab is executed. Basically, it is a cloud-based um, services, so it is internet, right? So right here you have your own PC or Mac, and here is your operating system. You simply just use a browser, right, to go to the Colab website, okay, and you attach on the internet, right? It will connect your browser to a remote services, okay. So in the Google's server, I think that it is Linux, and also maybe, okay, it has GPU, which helps you to do the very complex computation, okay. So after that there is website, of course, that is googlecolab.com, right? Googlecolab.com, and there will be a lot of kernel right here, okay. So basically, when you execute your codes in your browser, and at that time your browser will establish a HTTPS connection from here to here, and at that moment the Colab web server will assign a Python kernel for you. And the Python kernel, it depends on your configuration. The Python kernel can access the GPU. So every time you execute some code, for example, a print hello world, okay? For example, print hello world. Okay, when you execute that in your browser, actually that code snips will be passed to the web server, okay, by using HTTP. Okay, it is a post message to the website, and the website will see where is your corresponding Python kernel. Okay, so they will ask you this code, okay, even on GPU or on CPU, and then the output of this code, which is hello world, right? It's a text hello world, will be passed through the HTTP connection back to the browser, and the browser, there is a JavaScript function that can dynamically extract the output of your code and path and show the result under your code. So that is how that is a very simple way to explain how Colab is executed. So basically, it's really depend on what. Let's take a look at this one. It's really depend on how you manage and use the Colab. Usually, I will use a Google account and set up a folder. Okay, set up a folder, and we can add Colab files in right here. For example, I simply just execute M02 right here, okay, and it brings up the interface, right, and I can change it to English version. Okay. And then Google provide free services. So at the right hand side, you can see that the connect means I would like to connect to the remote Python kernel, so that it says connecting. So the Google will provide a Python kernel for me to execute this Jupyter notebook. Sorry, the IPython notebook. So here you can see that the most important thing you need to know is the runtime. There is a change runtime type. So it depends on what kind of account you have. So if you use a free Google account, you can choose CPU or some certain type of GPU. But if you pay Google to buy Colab Pro, there should be some even more advanced GPU for you to execute. That makes your program run even faster than some old GPU or CPU. Okay, so I choose a V100 GPU right here, and I enable high RAM so that I can execute it, my code, okay, which is M02 on Google's server, use their CPU and GPU. Okay, so it's really depend on you to buy Google Colab or Google Colab Pro or not. My suggestion is that you don't need to buy Colab Pro to for this class. Okay, if you have certain complex task to do, and you can buy Colab Pro, but it is not that necessary for you to do so only for this class. Okay, so we can see that I can here are some videos, so you can take a look if you want to. So since the Colab, the underlying operating system is Linux, right? So there you can run Linux command in Colab. Okay, there's some command right here. We will show you how to run some command with our data analysis later. Okay, but I show you there are lots of command can be run here, and there is a magic command provided by Python. Okay, so here is it, and again we will show you how to use some of the command to help us to analyze data. Okay, I will show you. We will show you later. Okay, and even you can write HTML tags. Okay, so that is the tag we draw this to square. Okay, and also it provides a way to write latex command, so you can produce a very nice, clear, beautiful formula, okay, or equation right here. So, and I would like to show I would like to show you how what is the difference between using CPU and GPU. But before that, recently Colab has a new functionality right here, which is called Colab AI. Actually, you can ask some question, and it will respond. And even you can ask Colab AI to, for example, here, how can I create a plot in Colab? It shows how to write this code. Okay, you simply just copy all those code and pass it into right here, and I think most of the time the AI, the answer from AI is correct. Okay, or you can say, how can I use GPU in Colab, and it also will answer you how to enable GPU in Colab. Okay, so here is an example which I wrote, and basically the only thing you need to know is this figure. I think I ask the CPU and GPU to do some very complex mathematics. Okay, so the more element I input to the function, okay, the more time, okay, the y-axis is the time, it need to cost a lot more time. But if you use CPU, you can see that it increased fast, right? But if you use GPU, that means you can concurrently, you can execute those function parallelly, which is more efficient when you calculate very complex mathematics equations or something like that. So basically, we recommend, if possible, then choose some certain, even if it's a very old GPU, you still much better than you use CPU to calculate the complex mathematic equation. Okay, and of course we will use certain different third-party library in our following classes, because we don't need to write some code from the scratch, right? We can just use those function, those APIs, those function, those libraries to execute what we want. Okay, so that is the code lab, something I would like to share with you. And at last, okay, I would like to show you visualized data analysis tool, which is called Orange. So basically, Orange is an open source project, which is recommended by Anaconda or some other analysis tools. We will show you how to analyze our security data by using Orange as well. Okay, not only use Colab, okay, write program. We also show you how to use Orange to analyze those things. So basically, you need to download the Orange. Okay, it has Windows version, it has Linux, it has Mac versions, okay, ARM versions or Intel versions, which is okay, whatever whatever computer you have, okay, you can install it. Okay, after you execute it, the interface, okay, looks like this. Okay, it has two different parts. Okay, left hand side is what we call widget, okay, and the right hand side is the canvas. Okay, after you install Orange in your laptop or PC, you can see that there are several different categories of the widget. But maybe you need some more widget, you can install it in add-ons. Okay, there are several different widgets which is not included in the built-in Orange. Okay, you can simply just click them and install them. Okay, but right now I would like to show you how convenient it is to analyze some data by using Orange. So that is okay. The very first thing we'd like to show is the data itself. Okay, when we analyze data, we need to import the data to the Orange, right? So I think there are three major ways to import data. The first one is file or CVIs or data sets. Okay, you can see that this widget has a dashed line at the right hand side, right? And you can drag data table, okay, to the canvas. You can see that the data table has two dashed lines, one at the left hand side, the other at the right hand side. Okay, so you simply just put your mouse right here and stop. Okay, it shows you this widget is data table, and the left hand side is input and the right hand side is the output. Input can accept a data called the left hand side can accept an input called data or data subset. The right hand side can output selected data or data. Okay, so first you take a look at this file. Because it does not has input, so there is no input. But at the right hand side, it says it can output data. So basically, you simply just click it again, and you can see that there is a configuration dialog. Okay, the first thing you can do is to click this item, browse document dataset. There are several built-in data set in orange. For example, we click this one. Okay, that is called iris. Okay, iris. And you have to know that orange is a very powerful tool, so that you can input several different types of data, including you can simply just edit your data or manipulate your data by using Excel and save the Excel file and import the Excel file in orange, which is okay as well. Okay, so that is iris. We say open. Okay, that means in this specific data set, okay, it says it has 150 instance, 4 features. Okay, basically it is a flower data set. So that is the septal and petal length and width. They have 4 different features for each flower. And there will be 150 flowers in this data set. And for each flower, it falls into different categories. So here we have the 5th column, which is what flower it is. Okay, there are some flower names right here. Okay, so that is, and then since the file can output data, so we can use your mouse to drag a line between file and data file. That means we output the file to the data table. So we click the data table. So here is the data set we import into the orange. Okay, it has 4 columns, right? So that is a number 1 flower. It belongs to Iris setosa, and its sepal length, width, petal length, width is right here, and we have 150 rows and 5 columns. 4 columns are numbers. 1 is categorical data. So that is very easy for you to observe those kind of data, right? Another one is the CSV file import. We will use it frequently later. Okay, if you edit your file in the form of CSV. Okay, and this one is the data set. Okay, there are also a lot of data set built in. Okay, most of them are educational, which means that they are very popular data set that being used in machine learning or data mining course. Okay, then some of them, we will use some of them later as well. Okay, so basically, after you have this data imported in your orange, then you can, for example, you can drag a lot of different widget which is related to data itself. Okay, so that we can see. Okay, that is the data information. That is the rank. That is the feature statistics. And you can see that this data can output to different widgets. Okay, the first one is data, the second one is data info, right? So we can click it. It says what is the name of this data and what is the size, how many rows, how many columns, how many of them are numeric, and what is their target. Okay, which is a categorical outcome, something like that. Okay, and rank. Okay, it's depend on. I hope you have done well in your statistic course. Okay, for each of the columns, okay, we can calculate some meaningful statistical numbers. Okay, for example, information gain, Gini, ANOVA, chi-square, something like that. Okay, we will not go over every, because I think most of them are taught in the statistics class. Okay, but it simply just show you those numbers. It's very convenient for you to observe the data. Okay, so here is the feature statistics. Okay, let's we can see that okay, it draw the distribution of different columns. For example, you can see that it's quite similar to normal distribution, and this one is not the normal distribution. Okay, including the mean, mode, median, Pearson dispersion, minimum value, maximum value. You don't have to write code to obtain all those very basic statistics values, numbers, because they Orange do such kind of things quite well. Okay, and even you can plot in a very fancy way. Okay, for each of the samples. Okay, what category they belong to? There are three categories, right? The blue, red, and green ones. So that is how the distribution cooperate with the labels. Okay, so you can see that we can visually say that for the petal length, okay, the blue samples, which is the small petal length samples, they all belongs to the blue category, and the blue one is okay. The blue one is setosa or something. Okay, so you can easily do such kind of things. So the transform, we will go over most of the widget in the later class, but I'll simply just show you some interesting widget today. Okay, for example, there's a data sampler. Okay, sometimes when we analyze a very big data set, you can simply just use a data sampler right here. So for example, 10% of the data. So after that, we can see that the data is data sample to data. Okay, you can simply just click the line. It says, okay, we sample 10% of data and we output the 10% of data to the right hand side. So it should be have 15 data points at the right hand side because we sample only 10% of data right here. So it makes you to manipulate those data more quickly and easily. Okay, select column, that means we can select we can select part of the column. For example, we have 4 columns right here and 1 target, right? We can simply just remove some of them or make some of them to be the target, something like that. We can manipulate those data. And select rows, that means we can filter 150 data points right at the left hand side, right? We can filter some data, remove them or add or combine them together. Okay, here's how we combine data. Don't worry about all those things. We will teach you how to do orange programming. Actually, it's not programming. It's just drag those widgets and connect them together. So here we have, for example, in our class website, okay, here is an orange column right here. So you can see that after this week, you have to take a look at the GSO video number 1, 2, 3, 4, and the IDS video number 1, 2, 3, 4. Simply just click the orange tab at the left hand side. Okay, and we can see that there is a list right here. So make sure you go to the go to the orange YouTube website and figure out which playlist it is. Okay, and take a look at the videos which I listed in our class website. Okay, for example, you need to take a look at the first 4 videos, right? So that is the first 4, and those videos are quite short, okay, less than 5 minutes. So I think it is very easy for you to watch those videos. Okay, so again, I would like to show you a very quick analysis. Okay, but you don't have to worry about it because I will teach you how to do it later. For example, most of the time when we analyze the security data, we would like to test. Okay, so that is the test widget. Okay, well, the test, what is the performance of different widget? The performance of different algorithms or model. So, for example, I have 2 pink models right here, which is regression and SVM. We will teach you how to what is the mathematics behind the logistic regression as SVM later. Okay, so I will test these two models. So it is quite easy that we provide those model to the tester, and we provide the data to the test. And make sure you take a look at this link. It says selected data to data. No, we need to output all the data to the right hand side. Okay, the select data means sometimes we can select data in the data table. So sometimes when you connect the line between data table to some other widget, you make sure that the entire data has been outputted to the right hand side. So we simply just connect these 3 or 4 widget, and then we can click the test, and it demonstrates that this model logistic regression is outperform SVM because its CA, which is classification rate accuracy, is higher than SVM, so that we can quickly do some test so that we can understand how the data is and how different models perform. And also we can plot, for example, right here, that is the plot. Connect the data to the plot, and we collect data to data. And then we can quickly visualize the data we import to the orange. Okay, we can choose what is the X and Y axis, right? And we can color the scatter by using different things. We can zoom in, zoom out. We can select different things, and we can output them. That's okay. That's quite convenient. So my suggestion is that every time we get a new data set, we can first import those data set in orange and try different models, try different visualization, try different data manipulation or data preprocessing. And after that, we know what the data is, and then we output those data to Colab, and we write program to apply a more complex algorithm to analyze those data. I think that is a better process to do data analysis, especially the data is quite complex. Okay, so I think that is good enough, and we'll stop right here. So next week we will continue. We will start our very first model. I think that is an important one, so don't miss the class.